Okay, we continue with tutorial number 9, a 10 centimeter high bump in a wide horizontal water channel. Create a hydraulic jump just upstream, neglecting losses except in the jump. For case here, y3 is equal 0.3 meter. So we need to estimate what is v4, y4, v1, and y1. So in this example, they give us a bump here, 10 centimeter, but the hydraulic jump is occur before the bump. So and then as I said, the energy is different between before and after the hydraulic jump. So means that for energy here, point number 1 here is not the same with the point number 2 because the location of point number 1 and number 2 is before and after the hydraulic jump. But if you want to compare the energy, you could compare with a point number 2 and point number 3 and point number 4 here, because all of this energy is actually after the hydraulic jump, and then it will always equal because the conservation of energy will be fulfilled here. So and then we go to calculate the velocity 4 and y4. So again, we assume that flow at the bump is a critical flow. So means that the Froude number is equal to 1. So we could calculate the value of velocity 3 is equal 1.72 meter per second. So flow rate at point number 1 in constant, in width which is constant. Okay, so this, I think you have idea of this one because the width is constant, so means that our calculation of Q times V here, so the A here is Y times width. So because the width is constant, so we say that the width here is 1 unit. Okay, so that's why we just use the terms Y here. So and then when we substitute their value, we could get that the flow rate here is 0.516 meter cube per second. So this amount of flow rate is actually can be used at all points. So and then we compare point number 3 and point number 4. So this is the equation of energy equation. So and then we substitute all the value, we get the equation number 1. And then we use the continuity equation to create the equation number 2 here. And then we could solve this problem. We get y4 is equal 0.195 and the velocity is 2.640 meter per second. Now we calculate the V1 and Y1. So we know that the energy 2 and this is the equation for energy at point number 2, and this is the flow rate at for point number 2. This is the total the amount of flow rate at any point, and this is the equation of continuity equation at point number 2. So and then according to this 2, we could calculate the value of y2 is 0.495 meter, and then v2 is 1.04 meter per second. So I think I hope you could try to do this at home. This is just the comparison between the energy equation and the continuity equation. So after we get this one, okay, so and then we need to solve problem at location where it is occur before the hydraulic jump. So we have one equation to calculate the value of y. So and then we get this one. So we have the y1 over y2, 1 plus 8 Froude number minus 1. So here I think you could compare this equation with the previous equation. So this equation is actually in the ideal condition. That's why we could change the subtitle here. Previously, we used the value at here, the value at point 2 here must be the value before the hydraulic jump. But if you switch because it is just the ratio between the float number and also the y. So why we could do this? Okay, I hope you still remember we have an energy curve like this. Okay, so and then what we calculate here is actually the value of y, and then we could reflect the value of y here with float number. So we have alternate depth and so on and so forth. So according to that, actually we could have that idea because the float number is giving the idea of energy. So but please study the location of y1 and y2 from the previous equation. So in this situation, because if we use a normal equation, we cannot solve it because we don't know the float number at point number 1 if we use y1 and y2 here. For example, we use 2y2 over y1. So we need to calculate the float number 1 here. So from this situation, we cannot calculate the float number 1 here. So then we switch the ratio. We reverse the ratio. So we calculate the 2y1 over y2. Now, we could calculate the float number here because point number 2 is already calculated here. So we could calculate the float number for point number 2. So we get the float number is 0.472. We substitute into equation number 3, then we could calculate the value of y1 is equal 0.165 meter. So and then from the continuity equation, we could calculate the velocity. So this is the equation. So and then we could calculate the velocity is 3.12 meter per second.